Thank you, everybody. My name is Daren Race. I'm going to be talking through some slides first, and Nupur will be doing a demo using the OCI service. So my background, as you saw earlier, is from information retrieval, worked in search and a few other areas at Oracle, but most recently on the data science platform. This was recently made into a native service at OCI. So the resources that we manage, like projects and notebooks and things, are fully OCI, full OCI services. So let me start off by giving a little bit of a background before we talk into the demo. I don't know exactly what the background of everyone is, so this is sort of assuming that people don't know anything about the service at the moment. So if I tell you something you already know, then please just forgive that. And this is a mandatory statement that we have to have in our slides. It just talks about anything I say can't be used against me. So the challenge is that the data science cloud service was originally conceived to address, and our roadmap targets, meaning we don't do all of these things perfectly as of today. The service went live in February, and it's a work in progress. It's continuously updated and continuously deployed, roughly on a monthly cadence. It depends. Different parts of the service operate on different cadences, but typically there's a new version every month or so. Each time we try to hit more of the roadmap and try to obviously fix any of the bugs that we've introduced between, that customers have found that we've introduced between changes. We are very much into innovation and not risk averse. We like to change things quite a lot. Sometimes we change things in ways that cause behavioral changes to users, but we try always to make sure that we're doing it in the best interest in customers. I'll talk a little bit about that a little bit later on, but the point is that this is a continuously integrated, continuously deployed service running on the cloud. So these are the target areas that we try to address. Oracle has competitors in this space, and those competitors each target a slightly different aspect of data science. Being an enterprise company, we are favoring things like compliance and reproducibility and recoverability and capabilities in hardware that you may not have access to yourself. A good example of that I will talk a little bit more about in terms of model understanding. So if you deploy a model that is giving credit cards to people or denying credit cards to people, you may have to prove in court that your model does not discriminate based on protected classes. We have mathematically provable capabilities in that area so that you can address those compliance questions. All of those are the sort of areas that, being Oracle, we are targeting specifically. We also, as a cloud service, we obviously handle things like scale and the development operations that you would have to do yourself if you're running your own service. I'm taking too much time on this first slide, but these are the areas that we target in the OCI data science service. I'll try to go a little bit faster. Model training, management, explainability. We are heavily into open source libraries. We are not currently open source. However, we are working on that. We are working to make more of our product open source. It takes a long time to do in Oracle, but it is a work in progress. Oracle do have some open source opportunities. For example, there's a Java library called Tribio, which I mentioned on this slide. This is already open source. Took them a year to get it to that status, but it is now. Our service is agnostic of packages because we are a platform. We don't care whether you want to use TensorFlow or Keras or PyTorch or scikit-learn. We don't care less, right? That's not our place to dictate what you should do. We are a platform that allows you, including OML, for example. We allow you to use whatever you want, and we encourage you to use whatever you want. We also provide those some capabilities that make it easier to use certain things over certain other things. So our key resources, by resources, I mean in the OCI Cloud's native services, you have to be resource oriented. So projects are a resource. You can create them, you can delete them, can't really update them. Well, you can update projects. The other key resources that we have are notebook sessions and the model catalog. The model catalog is agnostic of source of model. So you can use the model catalog without using our service to create the models. The model catalog, while being public and in general availability, it's definitely a work in progress because the area of model deployment is undergoing quite a lot of development. We're working on this area to make it much improved. We can't talk about it too much, but a little bit later on that. So model lifecycle. We address each of these to varying degrees of goodness. Model training, as I mentioned before, we don't care how you train your models. We do offer the Oracle Labs AutoML functionality. So if you want to train models with AutoML, you can. And that's as simple as data set in, model out. You don't have to do anything. It feature selects for you. It picks the algorithm for you, tunes the hyperparameters, and it builds you a model object. So that's if you want to do that. We also have a hyperparameter optimizer. So if you specifically want to pick which features you want to use, and you specifically want to lock down certain hyperparameters, but you would like to have something tune the remaining ones, we could do that for you too. Evaluation is an area that we cover pretty thoroughly. We can take a model that we produce, AutoML produces, or you produce outside, and do sophisticated both visual and compliance recording of model evaluations. This is things like how well does the model perform across one or more data sets? How well does it perform on the test versus train, to give you an idea of how generalizable the model is? How effective is, for example, a classification model, it will give you individual scores, F1 scores for each of the classes. There's a variety of different evaluations that Nupur will probably show in her demo. Model explanation, this is, some people may be familiar with Lime, and you might be thinking, well, I can already do this with Lime. This is better than Lime. By better, I mean, we don't claim it's better. It is mathematically provable to be better. In the centroid of features, meaning when the features are typical of features that the model was trained on, Lime and our model explainability works about the same. As you get towards the periphery of that, as you get to the edge cases, our model explanations are stronger, are better. So meaning as the localization decreases, our model explanation capabilities outperform Lime. Model deployment, this is an area that we have a solution today, we have a better solution coming. Model monitoring, we have little in the way of this at the moment. We do have some, for example, performing model drift. Drift is when you start to use features in the model scoring that it wasn't really trained on. They're not typical of the training. So it's going to give you a drift in its performance. We don't have a fully managed drift performance monitoring at the moment. That's something that is coming later, but we do have something in this space currently. You can just read this. Cutting edge model explanations, cutting edge AutoML. It's faster than many other AutoMLs that are out there. Whether it's better is debatable. It's better in some cases. We can clearly show you cases where our AutoML is better. However, our competitors can show you cases where theirs is better. So it all depends on your specific data set and your specific target that you're trying to do. By target, I mean what you're trying to actually achieve in your AutoML. So now there's a few screenshots showing what the service looks like as an OCI service. These look just like all other OCI native services in that when you create a project, for example, you see the same kind of things as you would see if you're creating any other resource in OCI. The project's resource is there to describe the kinds of work that you're doing and to organize your notebook sessions and your models around a common project. Notebook sessions are instances of Jupyter Lab that is running on a virtualized shape. So you can pick the shape, you can pick anything from 2 cores to, I don't know, lots of cores. I think it's 64 or 128. I'm not sure what the upper limit is, and it constantly changes. You can also attach block storage of any size you want, from 50 gigabytes to something extremely huge. You can connect one or more VCNs so that you can connect out from your notebook to either the internet or to other OCI services. And then the part that my team specifically work on is the ADS SDK. This is designed to, first of all, it helps you as a data scientist manage the OCI resources. OCI resources are very geeky and written for software engineers, not really written for data scientists. So our library puts a data science front end on some of those services, which makes it easier to use. It also has connectivity capabilities to data sources inside of Oracle. Now you can connect to Oracle, the database that is, using CX Oracle, and you absolutely can do that if you want to. But we have in our library, we have capability of reading Oracle data sets and issuing queries that are faster than CX Oracle. Now, people in the CX Oracle team will challenge that and say you can't be, but we use Dask, which is a distributed multi-threaded system. So we're actually issuing partial queries on the data and assembling them in the background. So it's not faster than CX Oracle, but it appears to be because we take advantage of a cluster. It is actually blindingly fast though. We can read the Oracle sales table into memory, which has got 1 million rows. We can do that in about 4 or 5 seconds. There's a variety of other things that the ADS SDK can do. For example, it can control the AutoML library, can control the model explainability and interpretation library. The model catalog, this is there for storing your model objects. They can be pickle objects, they can be zip files. You can put whatever you want in there. It depends on the interpretation of what's stored in the model catalog. Currently, we offer a functions deployment, which is similar to Amazon Lambda. The idea is that it's just a function that you stick a load balancer in front of, an API gateway in front of, and you have public-facing access to a Python function. That Python function is then tied to the model object, which does the inferencing. We are working on a fully managed deployment that is easier to use than functions. Functions is easy to use, but a fully managed deployment will be easier from a data science perception, because it's not just a generic Python function, it is specifically a model inference endpoint with things like schema validations, the ability to aggregate across multiple models, to CDN the model across different global regions. All of those things will be taken care of in a fully managed service that is coming later. So what's new? These things I have to be careful what I talk about. This is actually in GA, so I can talk about this. Notebook sessions have metrics. So when your notebooks are running, you can watch the resources that it's using. I mean, why would you want to do this, right? Well, your IT department might want to do this, or you might want to watch it to find out which notebooks are taking the most amount of resources. You can also set alarms. You can create alarms on different resources. So if one of your notebooks is using a GPU, which can be expensive, if it's using a GPU for a very long period of time, you can set an alarm to let you know. This one, we don't have a user interface for model deployment at the moment, so I picked one that seemed appropriate for the model catalog. This is something we'll show you a little bit of later. I think Nupur is going to show this, but if not, this is very much a work in progress for the Data Science Cloud Service. What we have today is being improved. It improves monthly, but it's being improved in a big way soon. GPUs, these are actually in GA now. We were blocked for a while on availability of hardware, but these are actually generally available now. We have up-to-date hardware. The A100s, which are blindingly fast, will be available in the data centers soon. I don't know when exactly. It's scheduled for some time around now, but even the hardware that you have today is very, very fast. Our data science platform can take full advantage of these GPUs. When you, for example, use a PyTorch or a TensorFlow library, you get the GPUs if you're running it on a GPU-enabled instance. We do not currently support distributed multiple GPUs, but we do support multiple GPUs on a single instance. So that's coming again at some point in the future, multiple distributed GPUs. Conda separation, this is probably one of my last slides, or one of the last main ones. This is a feature that's currently in LA, limited availability at the moment, meaning most people here can't see this, but we can still talk about it because it is in limited availability. It will be in general availability soon. I'm not allowed to say dates, of course, because they can change, but it's the ability, previously or currently for most people, you get a Jupyter Lab environment that is set up for you that has a variety of packages. What we've decided to do, what we've done to make things better is that now you get a Jupyter Lab environment with a very basic Conda environment. We then have a browser, a tool that allows you to browse what we call service packs, not necessarily the best name, but these are Conda environments either aligned around functionality, for example, a natural language processing Conda pack, which may contain the libraries that pertain to NLP. A Conda pack for financial analysts, where it again contains all of the Python packages that allow financial analysts to do their job. But they can also be aligned around like hardware. We have some that work well on GPUs. We have a deep learning Conda pack. We have a SQL Conda pack. The SQL Conda pack comes with SQL Magic pre-installed so that you can connect to a database, an Oracle database preferably, and then you can perform SQL statements in the notebook. So we have a variety of these Conda packs. We are building more of them. These are something that you can fork and modify and publish to your own tenancy. You could build your own and import them. You could also export them. Now, exporting comes with some licensing restrictions because some of the packages, some of the Conda packs can contain Oracle proprietary code like AutoML. So, but apart from the ones that are flagged as being non-exportable, they are exportable. Immutable, this is, if we make a change to one of these, we make a new version of it. That's important because let's say that you want to use the TensorFlow 2.4, and then we go and bring out a new environment that contains TensorFlow 2. Something else, 2.5, 2.6. Currently, pre-Conda separation, you would be updated, and it's just too bad if you don't like it. After this Conda separation change, these environments survive. They're stored locally. So you get to choose. If I want to update to the latest one, you absolutely can. You browse the environments, you pick it, you go with it and carry on. If you don't want to, if you want to stay on the version you were with, including the packages that you added to the environment, you absolutely can. So this was a much asked for feature, and this is going to be available soon. So I am coming to the end soon. I got this slide from our product management team. I have no idea. It's free for 30 days, but it says it's crossed out, so I'm not sure if it still is. We are also hiring. So if anybody here is a machine learning engineer that is good at Python, if they are a software engineer that's good at Java, or they are a data scientist and good at solution engineering, please get in touch with me. And now I will hand it over to Nupur to do her demonstration.
Yeah, thank you, Daren. Let me share my screen. All right, is it visible?
Perfect.
Yeah.
Great. Okay, so thank you again, and thanks Roger and Charlie for introducing us and moderating throughout. My name is Nupur Chatterji. I joined Oracle in March of this year, so right before everything went remote and everyone started working from home. And I work with Daren on the Accelerated Data Science, or ADS team. And I'm really excited to show you most, if not all, the things that Daren has talked about this morning. So the demo that I'm going to do is going to be in 3 sections. So the first section is going to be an end-to-end walkthrough of how our platform can be used by medical workers, for example, to detect pneumonia in patients using images of their chest x-rays. And our platform, our service, is going to be the primary tool that enables that solution. The second part of the demo will be going through predicting housing prices in the suburbs of Boston. And again, this demo will, this portion of the demo will show you how the libraries that Daren mentioned, like ADS, AutoML, and MLX, can be used to their maximum capability. And then finally, we'll end with a short demo of how the data science platform encourages and makes using Onyx very easy. So Onyx is the open standard for machine learning interoperability, and this is something that we're working on, and it makes sharing models and rerunning models a lot easier. So with that, now we have a brief overview of what we're going to go through. Let me open up the service. So the service, as Daren mentioned, has just GA'd in February of this year, and it makes it very easy for customers to build, train, manage, and then even choose to deploy their machine learning model into the cloud. And one thing I want to highlight here is that it's really good and promotes collaboration in teams. And one way it does that is using these projects, which are one of the resources we mentioned in the presentation. All right, so hopefully this hasn't timed out. It has. Quickly log in again. So you can think of a project as being analogous to a collaborative workspace, and data scientists can convene, if you will, remotely convene to conduct all their data science work, whether that's trying out new methodologies or proving business KPIs and other metrics. And it's pretty easy to filter using these little tabs, and I can find my project here very easily. And you can firsthand see, a couple of my colleagues also working on other active projects. So is proof of the potential for, promoting collaboration. So let me go ahead and open this project. So again, on the left-hand side here, you can see the resources that we offer. So we have notebook sessions, and we also have these models, which is part of the model catalog. So the first thing we're going to do is create a notebook session, and data scientists or whoever's working on a project can either choose to have one notebook session that they share amongst themselves or have separate instances, and you get a summary screenshot on this table that you can see, and it gives you an idea of what status each notebook session is in. So now let's go ahead and see how we would create a notebook session. And this is a screenshot that you saw in the slides already. So you would go ahead and name a notebook session. You can choose the compute instance shape, and we offer lots of shapes. And based on how much data a customer or user has, we recommend they pick the shape accordingly. So if they have a large amount of data that they want to use and process, then you would recommend that they use a larger shape. And they have a smaller data set, they would use a smaller shape, and so forth. And again, here, block storage size. So you can choose anywhere between 50 gigabytes to 1 terabyte. And then you attach a VCN and subnet. And when we're working, we tend to use a combination that customers like, and they tend to like one in which they can access the public internet. So once these are all set up, if you type this in, how much block storage you want, then you're ready to create a notebook session. So I already have one created for this demo, which I'm going to open up. And when it opens up, you'll see the Jupyter Lab IDE, which is very familiar for data scientists. Jupyter Lab is basically an interactive environment for Python developers, and they can do all their Python coding, and whether that's related to feature engineering, model training, model deployment, you name it. So it's a pretty standard offering for data scientists. So now, as Daren mentioned, we have this managed machine learning conda separation project currently in LA. So I'm going to give you a little sneak peek into that to see how we're going to be using it. But keep in mind that, again, this might change and will definitely be updated by the time it gets to the GA stage. So the way it's going to work is that once you enter this Jupyter Lab IDE setting, we have this little icon to go into the Environment Explorer, which is a extension that our team has added. So once in here, you will see initially all the service-defined packages. So like Daren was saying, each of these is geared towards a different function, if you will. So we have a general machine learning package. We have one for Onyx. And since we are package agnostic, each of these will have multiple useful packages relevant for that task. So for example, in the machine learning pack, we have XGBoost, LightGBM, Keras, TensorFlow. So the user has the opportunity to use whichever one they prefer. And similarly, Onyx will have Onyx itself and Onyx runtime. So one thing to add at this point is also that customers are able to augment any of these by installing their own libraries. And that helps to customize almost each of these packs to their specific use case. So another thing I want to just highlight over here is ADS, MLX, and AutoML. And these are the three Oracle proprietary packages that we've been mentioning through the presentation. So ADS is built internally by the OCI data science team, and it provides comprehensive snapshots of the data set that you're going to be using. So there's a lot of useful information, including ROC curves, precision recall curves, and other such summaries and visualizations that help with data scientists who want to do their exploratory data analysis. We then have MLX, which is, actually, let me talk about AutoML first. So AutoML is a package that is used to automatically tune a model class and therefore help to pick out the best possible model. It works on any supervised classification or regression tasks, and it essentially automates the three main steps of the machine learning pipeline, and it does so by automating feature selection, algorithm selection, and also hyperparameter tuning. And by doing so, it minimizes the amount of human interaction, if you will. And then finally, we have MLX, which stands for machine learning explainability. And this is another really integral part of the machine learning pipeline. So just understanding and being able to explain what a machine learning model is doing and verifying that what it is doing is in fact consistent with what you expect it to do or want it to do is really powerful, especially as data scientists try to build more accurate and more powerful models as we go forward. So data scientists benefit from having this one cohesive space where everything is, all these packages and libraries are provided for them, so they don't have to go off on their own and install and manage a whole plethora of different versions conflicting and stuff like that. So it makes development for them a lot more seamless and easier and therefore more efficient as well. And again, just to highlight, they can, augment any of these packs by installing any other packages in addition to the ones that we provide in each of these packs as well. Okay, so I have already set up our environment for this demo. And let me move the Zoom chat away so I can see my screen. Okay, so this is our chest x-rays demo, as I mentioned, and we're going to be using a convolutional neural network model to basically see how medical workers can predict whether or not a patient has pneumonia using images of their chest x-rays. And the reason that this is even a viable option, or that we can think about using machine learning to do this kind of task, is because machine learning algorithms have very predictable error rates. You also don't have algorithms ever getting tired. There's no element of human exhaustion that impedes their performance. So that's another thing to keep in mind. And actually, there have been multiple studies which have shown that algorithms can repeatedly and with higher accuracy outperform trained medical professions when it comes to predicting certain tendencies in different diseases and conditions. Okay, so a quick summary of what this demo is going to do. It's a very typical supervised binary classification task. So our data set contains images, labeled images from patients who have pneumonia. So those are labeled as pneumonia, and patients who do not, and that is labeled as normal. And then the algorithm goes in and figures out what features in these images or scans of the x-rays are predictive of the disease, so predictive of pneumonia. And then what we do is apply this learned mapping or model to unlabeled images. And in effect, what that does is it gives us the opportunity or capability to predict on an unlabeled image whether a patient has pneumonia or not. Okay, so let me start scrolling through our notebook. So here we are loading the data set. Our data set was stored in OCI object storage, and we're just calling it into this notebook using a pre-authenticated URL. And we just want to add here that users can also import data from other data sources that they may have as well. including ADW. So as we keep scrolling further, you can see that this data set contains 383 x-rays of patients who do have pneumonia, and just under 1,400 images of x-ray images of patients who do not have pneumonia. So as we keep scrolling, we'll come to this data profiling section, which is that exploratory data analysis that I was talking about. And the way we're going to do this is using the ADS package, the first Oracle proprietary package that I mentioned. So the major benefit of this show in notebook function or method that you can see is that it's a short one-line function, but it's providing a whole bunch of summary information. So simple information such as the number of rows and columns in the data set, but then you also have slightly more involved information like feature visualizations. If I scroll down further, you can also see correlation maps as well. Oops, just jumped. Oh, the correlation is not shown right now, but if the data set allowed it, the correlation map would also be there. So as I keep scrolling, you'll see various other kinds of plots and visualizations that would help with, again, understanding the underlying trends and patterns in the data set more. So once we do that, we move on to the training of the model. And as I mentioned, we're going to be using a convolutional neural net, or a CNN. And we're doing this with Keras in this case. And just for context, because I'm using the ML Conda pack that comes with Keras, TensorFlow, LightGBM, etc. In this case, I can use Keras, which is what we're going to do. So in this diagram, you'll see we're using a pretty simple 2-layer CNN to build our model. And you simply have to build it layer by layer. This is something, there are tutorials from Keras to do this. And once that's done and I train it over 10 epochs and I'm happy with the accuracy and satisfied with the performance, I can choose to save my model, and it gets saved to the model artifact, as a model artifact, into the model catalog, which refers back to this section. And it would show up over here under models in our resources. Okay, so as I said, once we are happy with our model, we can go ahead and save the model to the model catalog. And then from this point, we move to deploying the function. So this portion, as Daren was mentioning, has a lot of configuration. So you deploy the model as a function, use the function as a backend to an API gateway, and that actually generates a function that you can invoke. So there's a lot of configuration involved. But the great thing is we have a notebook that does this for us. So in this notebook, you can see that we're using our function management client, and then that creates the app. And then finally, we can invoke the function that was deployed and apply it to an unlabeled image. So in this case, we have this payload.json file, which is just a 2D array containing the pixels of the X-ray image that was scanned of a patient who has not been diagnosed yet. And when we invoke the function that we have deployed on this unlabeled image, we get a summary in English says that your diagnostic is that you do have pneumonia. So this is just a brief example end to end of how our tool can be used. And I guess it is a good point to also say that this kind of exercise is very similar, can be considered very similar to, in the context of our current pandemic, triaging patients who have COVID-19. And it's also worthwhile to see how we can, harness technological advancements to improve the situation that we're in. Numerous studies have shown that machine learning can be trained on large amounts of data to build reliable and scalable models, and that's very promising for us. you can imagine a situation where, there aren't enough doctors, which some countries are facing this in around the world in the pandemic. You can imagine other medical trained professionals using this tool to help triage patients and sending, serious cases who are more likely to have a particular disease directly to the doctors instead of everyone getting sent to the doctors. Another example is you can imagine doctors themselves using this AI diagnostic tool to build their own confidence in a particular hypothesis that they have. So if they believe a patient has a particular condition, they can almost double check or augment their confidence by seeing what the algorithm has to say about the situation. And in doing so, hopefully the idea is to reduce any errors or mistakes that might happen. So ideally, this would, reduce the diagnostic load on doctors and also radiologists if it's X-ray related. So that's the first portion. Now let's shift context and move to our Boston housing pricing example. So this one is going to show us how ADS, AutoML, and also MLX can be used in conjunction to build a model and understand what is going on and understand the general underlying model behavior, if you will. So the beginning of this demo is pretty similar. So you load your data set and then you can use ADS to get more summaries and understand what is going on inside the data set, just like in our previous notebook. Again, you'll have a lot of informative diagrams and stuff like that for data scientists to use and understand the data set more. And then the next step is to use Oracle ML to build a model. And as I scroll down, you'll see a lot of output and useful logging, but the most helpful portion is right here, which is the summary table, and actually tells you which features were selected, how many features were selected as the most important for the model, and the final algorithm that was selected to build the model. So this is, again, a useful exercise for data scientists, and we're providing the tools for them to do that. You can scroll down further, you'll see the option for model evaluation, and this is something Daren was alluding to. So you have QQ plots, plots that show you residuals and stuff like that. Again, important information for users to have as they're trying to build new models and understand what's going on in the data set. And then finally, we move on to our model explanations, and this is done with MLX. So let me again bring your attention to some of the diagrams, because those are probably the most effective way to see how helpful and powerful this can be. All right, so let's consider this one. This is actually showing us the most important features that the model has picked. So here we have LSTAT, which is the percentage of homeowners in the neighborhoods considered to have lower status workers. We have RM, which is the number of rooms in a house, and NOx, which is a nitric oxide concentration. And those were the top 3 features identified by the model given this particular data set. And again, this is just a good way of understanding, it's good insight to have, what the model is actually prioritizing as more important versus features that it isn't considering to be as important when it comes to predicting the prices of housing. There's also, in this case, we can see all 11 features, but we can also truncate this and only look at the top 5 if we need to. And then as I keep scrolling, you'll see some more plots, and these are the PDP plots and the individual conditional expectation plots as well. And these plots help to explain MLX explainability, explain the the marginal effect that specific features have on the final prediction that the model makes. So again, if I keep scrolling down, we can look at this one. Let's look at this one. So this PDP plot is for RM, which is the number of rooms. So independent of all the other features in the data set, this plot is showing us that as the number of rooms increase along the x-axis, the price of the house also increases. And this is a good sanity check. It aligns with what one might expect, more rooms in a house, more expensive. So again, it's a good way to understand what is going on in the machine learning model, which is something that often feels like a black box that no one knows what's going on inside. So this is a good way to look into what is happening. As we scroll further, we see these ice plots, and ice plots are showing the result of every sample in our data set. And it shows the result of every sample in our data set when a specific feature is set at a specific value. So here we can see as the RM changes, some housing prices are more sensitive to that. But the median again shows that as the number of rooms increases, the price also increases. So it gives us again more confidence that the model is doing or behaving in a manner that we expect it to be. Okay, so now we'll move to the final short demo. And this notebook is basically geared to show you how the OCI data science platform is now working towards making using ONNX and generating ONNX files a lot more seamless. But before getting to that, I want to quickly bring your attention to this little corner over here. You can see that I'm using a conda env specifically for ONNX, as opposed to in the housing demo, I was using the ML CPU conda environment. So this is just showing you how in the same project, in the same notebook session, I can have different notebooks doing different tasks by using the power of these conda separated packs. So the ONNX, I haven't actually used this before, so one of my teammates was explaining this to me a couple of days ago. Basically, ONNX offers a great opportunity for integration, and it's very helpful, particularly for cross-platform model sharing. It's very useful to save a model, and then at a later time you might want to rerun it. So using ONNX is a great way to do that. And usually saving a model to ONNX can be a lot more involved, but what ADS is offering is a very clean and simple way to do this. So again, our notebook starts off in a similar way. We load our data set, build our model, and then when it comes to generating the ONNX model, we provide this not even one line, one word function called prepare that prepares the model, the ONNX file for the model for model types that are of AutoML, sklearn, XGBoost, PyTorch, and so forth. So again, it's a quick way to generate an ONNX file from a model that you've built. And then once it has been built, it's very easy to, here you can see a diagram of the network that has been built and then zipped up with ONNX. And here is, it just takes a few lines of code to actually use the ONNX file that has been created to rerun the environment using ONNX runtime, which was another library that we packaged with our ONNX conda pack. So the main takeaway from this portion of the demo is just that we're offering a very quick and easy way to actually create these ONNX files, which is usually a more involved and tedious process. So with that, it brings us to the end of the demo. So I hope this has given you a good overview of the entire service, and also maybe a bit of an understanding as to what ADS, MLX, and AutoML have to offer. So with that, I'm going to stop sharing, and Daren's going to join me again to answer any questions we might have.
Thank you, Nupur.
Thanks very much. There were some questions, but to be honest, most of them have been answered by Charlie. I don't know, Charlie, if you wanted to just summarize them just so that the general audience can hear the answers.
Well, there were some questions about what's the difference between OCI data science and OML, and I said, well, OML is inside the database, and OCI data science is embracing open source, and maybe you guys want to talk a little bit more about that in more detail.
Yeah, I mean, I do think it is confusing for people, especially in this TechCast where back to back we see similar things, right? So I think you're absolutely right. I think it depends upon the persona of the person doing the data science. If you're a DBA or a database person that prefers to use SQL, or you have a large amount of data that's in the database and you don't want to pull it out or can't move it out for compliance or other reasons, or you want to use the model in the database, OML is absolutely the best way to go, right? I mean, it's pointless pulling the data, building a model, using it to score data, only to write the data back to the database. OML would be clearly a choice there. If you're a data science persona, a data scientist that comes from the persona of they're used to writing notebooks, OML has notebooks as well, but they are already familiar with certain packages. Let's say they've been using PyTorch for 5 years and just want to carry on, right? Or their company have their own Python libraries that they want to use, right? Then they can't put those libraries in the database. Those libraries live outside, and the data science cloud service is a good choice for you there. Also, the hardware, being able to run deep learning models on GPUs, I don't think the database has GPU capabilities as far as I know.
Let me check on that. The answer is no. You don't have GPUs, not yet, at least, not yet.
Yeah, so that would be another area. Like if you're doing a lot of images or sound data science and you want to use GPUs, then our platform, the data science cloud platform, would be the clear choice. So it really depends. They're not competitive in the sense that they don't appeal to the same persona. They don't appeal to the same problem space. They work together. I mean, we the data science cloud service, embrace OML, and the Python library that it has, we will totally make that part of our platform too. So, it's not, you don't have to use one or the other. You completely can use both, and should as appropriate to the circumstance.
Yeah, and I think it's kind of wishful thinking to think any one product's going to solve all your problems, right? There's a multitude of different things, and this machine learning space is evolving and rapidly. So we have some stuff that's in the database, we have stuff that's outside the database, we have other stuff that's inside of applications. So you really have a lot of different choices and options, and there's some integration between some of the products today. There's more integration that's coming. You've probably seen like the Oracle Analytics Cloud is starting to reach out to the different machine learning application, machine learning options at Oracle. So I think you'll see more and more sort of tearing down of walls between these different things. But yeah, it's all the above for us these days. You can use all of them.
Yeah, and just to recap a little bit about what Nupur was saying about Onyx, right? So this again is talking a little bit to what Charlie just said. The Java library in open source provided by labs called Tribio, that produces models in Onyx format. We can convert models to Onyx format. The beauty of Onyx is that it's consumable by a variety of different runtimes. You can build a model with Python and score it with JavaScript, for example, or you can score it with a very high performance C runtime. You can import Onyx models that you found on the internet. Microsoft Azure has a set of them that are in their GitHub that you can just download and use them. So Onyx is a portable model format that we are definitely working towards integrating into our platform. So that, sorry, go ahead, Charlie.
I didn't mean to, go ahead, finish. Oh.
So that's another area where we would like to see cross-platform model deployment, right? So build a model with OML, score it with data science, build it with data science, score it in the database. Yeah. That's definitely an immature technology currently. Onyx will improve over time and we'll have more capabilities in that area, but that's definitely a trend we'd like to support.
Yeah, I was going to say we didn't cover very many futures, but I alluded to the Oracle machine learning for Python that's coming. I'm just going to say later on this calendar year, but also we have the Oracle machine learning services, which will support Onyx model, deployment, importing an Onyx model, perhaps generated from OCI data science, then scoring it. inside the Oracle machine learning services. So there's more and more of that coming. There's also the AutoML that is inside OCI Data Science. We have our AutoML that's inside the database, and those are overlapping in terms of their heritage. They both sort of stem out of some work out of Oracle Labs, but their implementation in OCI Data Science takes advantage of the whole plethora of open source techniques, whereas ours takes advantage of the 30-something techniques that we have, the power tools inside the database. So there's there's a lot of sort of Venn diagram sort of overlap more and more these days. Anything else? Any other questions we're looking at? We're trying to keep. We've got at least another trivia question, and we're going to try and wrap up. Any other quick questions for the OCI Data Science team that we haven't covered yet?
Not that I can see. They've all been answered. So.
All right, we should fade to black for Wayne's recording of this. So we're going to pause.
Pause.